the vast expanse of the cosmos, a universe filled with mysteries too grand and profound for the human mind to fully comprehend. Now imagine, nestled within that vastness, an object so dense, so powerful, that it defies all conventional understanding of the laws of physics. This is the neutron star, an object born from the violent death of a massive star, leaving behind an incredibly compact core with a mass far greater than our own sun, but compressed into a sphere only about 10 to 20 kilometers across. The forces at play are so immense, so staggering, that they warp the very fabric of space and time itself. As we ponder the true nature of these cosmic giants, we begin to realize something astonishing. Time itself is not absolute. It is flexible, malleable, and can bend and twist in the presence of immense gravitational forces. And no object in the universe exemplifies this more vividly than a neutron star. These stars, spinning with incredible velocity, create a reality where the very concept of time becomes distorted, stretched, and slowed down to a point where seconds near a neutron star could stretch into centuries for someone far, far away. Now, imagine for a moment that we could harness this incredible force. Imagine that, within the confines of these powerful objects, there might lie a doorway, a crack, a tear, a fissure in the cosmic fabric that could allow us to manipulate time itself. Could a neutron star, with all its mind-bending properties, serve as the very key to time travel? The idea seems almost impossible, yet there is something tantalizingly intriguing about it. If the intensity of gravity around a neutron star can slow time down, then it stands to reason that the opposite might hold true, too. Could we, perhaps, use the warping of space-time to travel to the future, to witness epochs long after our time has passed? And yet, we're left with the nagging question: could we ever travel backward, revisiting the past, rewriting history? To answer that, we must first understand the mechanics of time itself. Let's pause for a moment and consider the very nature of time. Time, as we experience it, is often seen as a linear progression. It flows from past to present to future, uninterrupted, unchanging. But Einstein's theory of general relativity shattered this simple view. His groundbreaking work showed that time is interwoven with space to form space-time, a four-dimensional fabric that can bend, stretch, and warp in the presence of massive objects. Time is not a rigid, unchanging entity. It is deeply flexible, influenced by the objects and forces around it. In the presence of a massive object like a neutron star, space-time is curved to such an extreme that time itself becomes dilated. Imagine standing on the surface of a neutron star, where gravity is billions of times stronger than on Earth. If you looked at a clock, you'd find that time would pass for you much more slowly than it would for someone far away, where gravity is weaker. It's a phenomenon we call gravitational time dilation, a fascinating and profound effect that's been observed in our universe. This dilation of time means that time near a neutron star could flow slower than for someone on Earth, or even slower compared to someone orbiting a black hole. So, could this provide a window into the future? Could this time dilation allow us to experience centuries in the blink of an eye, while on the outside, time advances normally? In a way, yes. If you spend a few moments near a neutron star, when you return to Earth, years, even centuries, might have passed. You would have effectively traveled forward in time, though you would have remained in the same moment as everyone else. A mesmerizing idea, isn't it? A tiny slice of time spent near a neutron star could unlock a journey into the distant future. The key to understanding the possibility of time travel through neutron stars lies in their extreme nature. These stars are not merely dense objects in space. They are cosmic laboratories, places where the rules of physics are stretched to their limits. Could we use these stars to leap through time, to reach forward, perhaps even beyond our wildest imaginations? To harness the full potential of neutron stars, however, we would need to understand not just time dilation, but the nature of gravity itself. If gravity warps time so dramatically, could there be a way to harness that warping? Could we create a pathway through which time could be manipulated, bending back on itself, allowing us to walk backward into the past? Unfortunately, while neutron stars offer intriguing glimpses into time's flexible nature, current physics suggests that traveling back in time would require something far more extraordinary. Something akin to wormholes or closed time-like curves, which remain purely speculative for now. But still, the potential remains, albeit more theoretical than practical. Even if traveling back in time might be beyond reach for now, neutron stars may hold the secret to experiencing time in new ways, to viewing the future from the vantage point of an object so extreme it defies our comprehension. The thought of a cosmic time machine, powered by the immense gravitational force of a neutron star, raises countless possibilities. Imagine the sheer magnitude of time dilation that could occur in such a scenario. Take, for example, a spacecraft venturing into the intense gravity of a neutron star. While the crew aboard the ship experiences only a few minutes, years or decades might pass in the outside world. It's not that they are traveling in time per se, but that time flows differently near such a powerful gravitational force. The closer you approach, the greater the distortion. The farther you travel away, the faster time resumes its normal rhythm. Could such a journey lead to new perspectives on our place in the universe? Could it be that in the future, we develop ways to use neutron stars and their time-warping properties to explore distant futures, to witness the evolution of the universe across eons? In theory, this might not only allow us to observe time, but use it as a tool to navigate the vast oceans of time itself. Yet, that dream is far from reality. It requires unimaginable technological advancements and, quite possibly, breakthroughs in our understanding of physics that we have yet to discover. While neutron stars may provide a spectacular window into the nature of time and space, the practical challenges of using them for time travel are immense. The intense gravity and radiation of these objects would obliterate anything that ventured too close. And even if we could survive, the technological hurdles would be staggering. Getting close to a neutron star would require us to travel vast distances through space. And it's not as if we can just hop into a spacecraft and take a stroll to the nearest neutron star. They are far, far away, often hundreds of light years from Earth, making them out of reach for any current or foreseeable mission. But this doesn't make them any less fascinating. The concept of neutron stars powering time travel, though far from a reality, taps into the very human spirit of exploration, discovery, and the pursuit of knowledge. Neutron stars, with their extreme gravitational forces, offer us a glimpse into the mysterious nature of the universe, where time bends, light curves, and reality shifts. So, while time travel may still be relegated to the realms of science fiction, neutron stars show us that time itself is far more fluid than we ever imagined. Perhaps one day, we will uncover the true power of these cosmic giants, unlocking the secrets of time itself. And even though traveling through time remains a dream for now, the fact that such a concept is even within the realm of possibility speaks to the endless mysteries that still await us in the universe. In the end, it's not about the destination. It's about the journey, the eternal quest to understand our place in this vast, expanding universe. And whether we ever travel through time or simply gaze at the stars, the universe, in its infinite mystery, will always be waiting just beyond the horizon for us to explore.